Welcome to the members of the 9th Physics School, Roberto A. Solomon, University of Brasilia, Institute of Physics, scheduled during 16th to 21st November 2020. Myself, Shiva Udachan, from Karnataka, Rani Chennamma University, India. Title of my talk is Influence of Post-Annealing on Electrical Properties of Silver Nano Films. Outline of my talk. It includes introduction, theoretical section, experimental techniques, results and discussion, conclusion. Now let us have a glance over the introduction. Silver and silver oxide nano particles have potential applications in fields of nano science and technology. Hence we address in this paper effect of post annealing temperature on the electrical resistivity of silver nano films. The resistivity of the resistance of the silver film was measured in situ by the standard 4-point probe technique for both annealed and unannealed silver films. Now moving to the theoretical section, the electrical resistivity based upon Fox-Sondemer and Mayer-Shakes theory can be written as rho upon rho naught is equal to 1 plus 0.375 L upon T, where T by L is greater than 0.1, and rho upon rho naught minus 1 is equal to 3 by 8 lambda into 1 minus p plus 3 by 2 alpha dash. So on, this is equation 2, where rho is the electrical resistivity of the film, rho naught is the resistivity of infinitely thick film, L is the conduction electron beam free path, T denotes thickness of the film, alpha dash is the grain boundary scattering power, where lambda is equal to T upon L. We have made use of these above two equations for the estimation of conduction electron beam free path speculative parameter and infinitely thick film resistivity. Now moving to the third part, that is the experimental section. Thin silver films were grown by resistive heating technique in vacuum onto chemically cleaned glass substrates. The thickness of silver films were measured by quartz crystal digital thickness monitor. The other experiments are given elsewhere. This is the thermal evaporation vacuum. We have made use of the vacuum coating unit. It consists of bell jar, substrate table, crystal monitor, substrate holder and sample, path of vapor, clamps connected to high current source, filament board filled with evaporant. You can also see high vacuum created by a diffusion pump backed by rotary pump. So the main procedure of the vacuum coating unit is whenever metal is heated to red hot, metal emits atoms. Atoms travel along straight line. If a cool substrate is placed in the path, condensation of atoms takes place, giving rise to formation of thin films. This is done under pressure of vacuum, that is 10 raised to minus 5 to 10 raised to minus 6 torr. Now we have used the four-probe technique. Four-probe technique. This is one of the important methods of measuring film resistance. Here, along the length of the conductor, 4 collinear points are chosen so that the distance between two adjacent points is approximately equal. You can have a glance at the circuit diagram. Now, constant current is passed between the output points. The quantities are described later by means of a constant current source, and the voltage developed is measured between the two inner points by 4.5 digits digital multimeter. Now moving to the fourth part, that is the results and discussion. You can now look at the figure 1. The experimental results obtained are shown in the figure 1 and 2, and the electrical parameters are present in the table 1. A reduction of 20 to 50% of resistance of 24 elements has been reported. Similar results have been observed for silver films. You can have a glance at the figure 2, that is low entity versus thickness of silver films. Table 1, annealing, it gives us knowledge about annealing based electrical parameters of silver films. The metal used is silver, thermal position non-annealed silver film and annealed silver film at 100 degree centigrade. The annealed silver film at 100 degrees Celsius for rho naught is 2.37, and for non-annealed silver film rho naught is 3.539. Okay. Pressure for the non-annealed silver film is 0. Pressure for the annealed silver film is 0.2. Here the conduction electron free path for non-annealed silver film calculated is 42.8 nanometer, and for the annealed silver film at 100 degrees Celsius, conduction electron free path is 14.54. Okay. Now moving to the last part, that is the conclusion. The experimental result of resistivity as a function of thickness reproduces Mayer-Shakes theory, whereas Fox-Sondemer theory holds good for higher thickness films for both annealed and non-annealed silver films. The annealing temperature at 100 degree reduces from 3.5392 to 2.37 into 10 raised to minus 8 ohm meter. Thank you to one and all.